Assalamualaikum warahmatullahi wabarakatuh. Bismillahirrahmanirrahim. Let's consider the first example for buoyancy. So in these questions, we are given a metal part 2 in this diagram here is hanged by a thin cord from a floating wood. So this is floating wood marked as 1. The wood block has a specific gravity S of 0.3. So meaning that the density of the wood will be 0.3 multiplied by the density of water. So it's 300. And the dimensions of the wood is 50 by 50 by 10 millimeter. And part of the wood is underwater. And the metal part has volume of 6600 millimeter cube. So we asked to find the mass of the metal M2 and the tensions in a cord. So now let's consider schematic diagram of the problems that we have here. So we have a wood. So the wood has dimension 10 by 50 millimeter by 50 millimeter. And then the wood is floating such that 2.5 millimeter is above the water. So that means that 7.5 millimeter is submerged underwater. So the specific gravity of the wood is equal to 0.3. And then the wood is connected to a metal part which is wholly submerged inside the water. And the mass is given by M metal. So we asked to find the mass of the metal. So the volume of the metal is given as 6,600 millimeter cube. And we assume that the density of water is equal to rho F is equal to 1,000 kilogram per meter cube. Let's first of all draw the free body diagram of the wood and the metal parts. So consider free body diagram of metal part and wood. If we consider the wood, so this is the wood. So part of it is submerged underwater, and given that this distance is equal to 2.5 mm and the whole distance is equal to 10 mm. So there will be buoyancy force acting upward. So I call that F buoyancy wood. And then downward is connected to the metal part by a cord. So tension in the cord plus the weight of the wood is acting downward. Now if you consider the metal parts, so this is the metal part, not drawn to scale. So we have the tension in the wire plus F buoyancy metal acting upward, and then acting downward will be the weight of the metal. Now we can balance the forces in the vertical direction. So balancing forces for the first of all wood part. So we can write F buoyancy wood, which is acting upward, must be equal to the tension in the wire plus the weight of the wood, right? So we are asked to calculate the tension. So tensions is equal to F buoyancy wood minus the weight of the wood, right? So now using our formula for buoyancy, F buoyancy wood will be equal to rho of the fluid multiplied by gravitational force multiplied by displaced volume. And now the displaced volume will be this volume here. So that is equal to 10 to the 3, 9.81 multiplied by dimension is 0.05 multiplied by 0.05 because it's 50 millimeter, and then multiply by this dimension, which is 7.5 millimeter. So that is 0.0075. So that gives me the buoyancy wood is equal to 0.1839 Newton. Right. So now, what about the weight of the wood? The weight of the wood will be equal to density of the wood multiplied by G multiplied by the volume of the wood. So the weight of the wood is 0.3 multiplied by 10 to the 3, where 0.3 is the specific gravity of the wood. Multiplied by 9.81 multiplied by the dimensions of the wood, so 0.05 multiply 0.05 multiply 0.01. So that gives me the weight of the wood is equal to 0.074 Newton. And from there, I just substitute it back to these equations. So I get the tensions is equal to FP wood 0.1839 minus 0.074. So I get the tension is equal to 0.11 Newton. So next, I can consider the metal parts and balancing the forces there. So balancing forces for the metal part. So I have T plus F buoyancy metal. Okay, T plus F buoyancy metal must be balanced by the weight of the metal. So the weight of the metal will be equal to mass of the metal multiplied by G. Mass of the metal multiplied by G is equal to tension plus F buoyancy metal. So this allows me to calculate the mass of the metal will be equal to T plus F buoyancy metal divided by G. So I can just, we have already calculated the tensions in the wire, 0.11 Newton. F buoyancy metal is just equal to density of the water is 10 to the 3, 9.81, multiplied by the volume of the metal. So it's given 6600. Change that to meter cube, so minus times 10 to minus 9 divided by 9.81. So that gives me the mass of the metal is equal to 0.018 kilogram. Okay, so if we recall what we did just now, so we consider schematic diagram. Then after that, we draw the free body diagram for the wood, floating wood, and for the metal part. And then after that, we just balance the forces on the wood, and that allows us to calculate the tensions in the cord. Then after that, we just balance the force for the metal. That allows us to calculate the mass of the metal.